Hello everyone. In this video, I'm going to show you how you can find the p-value or the probability value for a particular t-statistic from a t-table. Now, as you are aware that the t-table is always going to be a truncated table for just selected special alpha value and also a selected number of degrees of freedom. Degrees of freedom are calculated from the sample size n minus 1 in the case of one population mean. And whenever we come to the table to find a t-value or an alpha value, a probability value, we should always come with information on df, because without the df value, we will not know which row to focus on. So in the case of probability values, p-values, we first have to know what the t-value is, the test statistic, t-test statistic is. So let's say I'm going to just come up with a t-value. All right, so let's say the t-value is 2.713 with a df. So again, you always have to qualify a t-value with a corresponding df. So let's say the df is 14. All right, so we have to find the p-value or the probability value for this test statistic, and I'm going to mark as t sub 0, indicating that this t-value is a test statistic we found using the formula to calculate a t-value. All right. So when we need to find the probability value, again, probability value is going to be a value between 0 and 1, correct? It's an alpha value. So what we do here is first we come to this table with the df and look down the first column until we get to a df of 14. So in this case, the df 14 is here. And now we are going to just focus on this particular row to look for 2.713. Now, since this is a very truncated table, we will never be able to find the exact p-value. I mean, we might by coincidence, by chance, but most likely we will not be able to get an exact p-value. It's going to be an estimated p-value. All right. So the way we will go about it is come down your df column until you get to the particular df that your test statistic is qualified with. In this case, it was 14. And now I'm going to go through this row looking for 2.713. That's our t-value. So we have the first one being 1.345. Well, 2.713 is greater than that. So look to the next column, 1.761. 2.713 is even greater than that. Then the next one is 2.145. So this is not it. Next is 2.624. And then after that, we have 2.977. Our test statistic value is 2.713. That means it will be somewhere between 2.624 and 2.977, correct? So once we find this location, once we find the place where our test statistic would be located, it's a value which is greater than 2.624 but less than 2.977, correct? So it will be somewhere in between this range of values. So what we do next is we go up the table and look for the two corresponding alpha values. All right. So for 2.624, the alpha value is 0.01, correct? So it's 0.01. And for 2.977, it's 0.005. So I'm going to write the lower value, the smaller value on the left-hand side, 0.005. All right. And because 2.713 is between these two t values, 2.624 and 2.977, the corresponding alpha value, which is also the p value, is going to be something between these two alpha values of 0.005 and 0.01. So the way you're going to write this is 0.005 is less than p, is less, just a second here. I'm going to rewrite this. We are going to write this is 0.005 less than p, less than 0.01. What this is telling us is the p value of 2.713 is going to be a value between 0.005. It's going to be greater than 0.005, but less than 0.01. All right, so it's going to be an estimated value. Make sure if you're using the table, you're writing it in this format to show that you have picked the correct range of values within which the probability or the p-value will be contained. All right, and then you can compare this range. You can actually compare the higher value with alpha to come to a conclusion whether you should reject the null hypothesis or not reject the null hypothesis. If it is a two-tailed test, however, you have to double up the number. Whatever p-value you found, you should multiply that by 2 and then compare with alpha. So to determine whether we are rejecting a null hypothesis or not rejecting a null hypothesis, it's comparing probability to check if it is less than alpha. If it's less than alpha, we reject. If it is not less than alpha, then we do not reject. That's the decision. But if it's a two-tailed test, make sure that you are multiplying whatever p-value you found by 2, because in a two-tailed test, the p-value will be spread between the two ends of the curve. All right. Now, if you are using a graphing calculator, then you should be able to get the exact p-value for any t-value, any test statistic, right? I think I posted a video for that, so you may want to look that up, but there are also several videos that you can search on YouTube and look up how they go about using the graphing calculator to find the p-value for specific t values. All right.